I'm Aaron from DataStax, and I'm here today to take you through a little bit about HCD or Hyper-Converged database and how to accelerate your AI applications with it. So yeah, let's get rolling here. Let's see. Well, it might help if I actually put the correct presentation. All right, so here we go. Okay, our agenda today is pretty simple. Oh, you know what? I am not sharing my screen, am I? I tell you, this one is starting with all kinds of hitches, isn't it? All right, let's say entire screen, and we're gonna go this one, and we'll share. All right, everyone sees an infinite window. Outstanding. Maybe I'll drag this one over here. And then go back to here. And we'll start. Okay, great. Well, welcome again. I'm trying to make sure that I'm centered here. All right. So yes, today we're working on, accelerating AI development with DataStax HCD or Hyper-Converged database. Our agenda is pretty simple. I'm going to talk through a little bit about HCD and what makes it different. We are going to go through a little of provisioning a cluster. Actually, all of the remaining points are going to be like demo live land here, and hopefully everything will work out well. We're going to have a look at the cluster as well through SQL Shell, which now you can do right through Mission Control. We're going to have a look at the DataAPI. And if you were here, I think it was last week. Yeah, if you were here last week, you would have seen me, give a live stream as well on, kind of leveraging, a lot of aspects of the DataAPI and the table API as well, which is part of the DataAPI. But yeah, well, that's for another session. Anyway, and then finally, we're going to hook up Langflow to our HCD cluster and see if we can get a small AI flow to work, and then maybe work with it in some other ways. So let me. All right. Okay, so HCD. We are getting a fair amount of questions about what is HCD? What makes the hyper-converged database or data platform different, from DataStax Enterprise or even open source Cassandra for that matter. The idea with HCD is that this is our path forward, into being able to, support, a lot of new integrations for future state. For instance, we have a lot in HCD and the newest version of DSE, DataStax Enterprise as well, about supporting things for building applications with generative AI, that use vector search and a lot of other things like that. We also have integrations with tools like Langflow. If you've been paying attention to DataStax for the last year or so, Langflow has been one of those things that we've kind of talked nonstop about. And if you haven't checked it out yet, I highly encourage you to do so. And actually, you'll see why at the end of this presentation as to why it's so cool and why we're talking about it all the time. And then the other thing is that we know that a lot of our customers like to use that Cassandra-based enterprise database with search. So we are actively building out an interface layer for OpenSearch to, kind of meet that need as well. And we know a lot of our existing customers are on a version of like DSE that integrates closely with Solr. And the idea is that we're also going to be building some tools and layers that kind of make that transition from Solr to OpenSearch as painless as possible. So we're kind of that's the roadmap there. You see right in the middle, we have this thing called Mission Control. It's what you might think is our replacement for DataStax Ops Center. What it does is it allows you to deploy, HCD, DSE, and actually regular Apache Cassandra as well. And you can deploy it out to any of the three major clouds, as well as to your own on-premise Kubernetes cluster. So that is really cool that Mission Control does that. And we're going to show some other things today to also kind of demonstrate some of Mission Control's capabilities and really what it gives you. So the idea with HCD is that it's innovation beyond just Cassandra. The thing is that with a lot of the big features that have been going into Cassandra lately, like ACID transactions for one, and vector search for another. But ACID transactions is one I'm kind of focusing on right now because it's right around the corner. But development on it and testing on it has really taken a little bit. So the idea, though, is that Cassandra may have some of its upcoming features blocked until that next release. But as far as HCD goes, our innovation at DataStax doesn't stop. So I mean, we go ahead and make sure that our enterprise grade products are using the latest and greatest edition of JVector for vector search, as well as the latest edition of SAI, or storage attached indexing. And the newest version of storage attached indexing gets you all kinds of cool things. It gives you an OR operator. You can do, excuse me, various operations with a little bit of pattern matching. And you can also sort by an arbitrary column with, SAI v2. So those are just some things that you get with HCD that aren't quite in Cassandra yet. And they will be. They're down the road. But yeah, HCD kind of gets you around that and gets you the latest and greatest. All right. Well, that's it. That's about it for the slides. I didn't have a whole lot. A lot of this is going to be kind of building and showing live here. So with that, let's jump over to Mission Control here. Now, this is Mission Control, if you haven't seen it before. Basically, I like to call Mission Control Kubernetes on easy mode. So it does a lot of the great things that you need Kubernetes to do without a lot of dropping to the command line and running kube control commands. I mean, there's still a little bit of that, but the Mission Control team is really doing a great job of extending a lot of that advanced Kubernetes functionality into Mission Control and making it so that things are just kind of on easy mode for you. I have a single cluster out here. Actually, this is my coworker Jeremy, who spun up a cluster out here. But you can see that kind of the cool thing is that when you click in, you can see the nodes. You get a view of the data center as well as some stats about it. You get built-in observability and metrics. Kind of the cool thing with Mission Control too is that if you don't want to use our metrics, you can absolutely plug in your own and configure that on the back end with Mission Control. Actually, I'm pretty sure I have a video out there where I've done that and actually sent the metrics from Mission Control over to like an external Prometheus installation. But anyway. Kind of the cool thing too is that you can look at the logs here as well, and kind of get a view as to what's going on with all the nodes, or you can just go by one particular node and see those logs. Really useful tool. We have a Connect tab up here, and the thing about the Connect tab is kind of like it does with AstroDB, is that you can go through here and kind of pick your language of choice, and it'll go ahead and walk you through building out like a simple connection-based application to go ahead and select from the database. Excuse me. So there's all that. We actually have a way to expose like the CQL gateway and deploy and expose the DataAPI as well, which we're going to get to in a little bit. But again, the idea here is that you can do this all in Mission Control. And then with the DataAPI, kind of as I showed last week, that you can actually access your database with like a RESTful type of configuration or request. Kind of also cool is that you can go right to the CQL console from within Mission Control. I'm not going to do it here because I don't know Jeremy's password, but I'll go ahead and show you on a different one as well. Let's see here. We'll do a leave. You can also initiate repairs as well. You can schedule them. And the cool thing is that kind of like Cassandra Reaper, it'll just kind of do this on its own. In fact, this does use Reaper on the back end on its own, but it takes you away from that work of having to set up a Reaper cluster and the Reaper application and then configure all of your clusters in it. Mission Control just kind of does it. All right, let's jump over to here. So this is my cluster that I have. It's called Farewell to Kings. Data center is named Xanadu. I have 3 nodes, and one of them is actually restarting at the moment. So we'll try to hope that these 2 nodes that are running here can keep us going. But if I have a look at repairs, you can see there's been a couple of repairs that have been done, even though I haven't. There are some active schedules. Oh, well, look at that. All right. But anyway, yeah, the point is that this is all super easy. One thing that kind of has not been easy traditionally with Cassandra has been backups. And, the cool thing here is that, you can go ahead and create a schedule for a backup. You can designate a data center that you want backed up. And it goes to your config. So you have inside of Mission Control, you can configure a backup configuration that has like an S3 bucket location or S3 compatible bucket store. And that's where your backups actually end up. So backups tend to get insanely complicated, especially in a very large cluster, and especially because each node and its token configuration is unique. So a backup from one node really isn't any good on any other node, which has kind of been, the blocker to a lot of people doing backups in Cassandra. But again, Mission Control just takes that out of your hands and makes that super easy. All right. So let's go ahead and take a look at what we've got here. If I go to the Connect tab, if I go to the CQL console here, let's log in. There we go. So you can see that I'm in here. Say describe key spaces. Actually, let me see if I can increase that sizing a little bit better here. There we go. I hope that helps some. But the idea too is that DataStax HCD is very similar to Cassandra. In fact, we can go ahead and do a select star from system local, and that should look very familiar to a lot of you. Same thing. I can have a look at system peers as well, and again, this is all very similar to to what we see when we do this in Cassandra. So it functions very similarly. We are actually going to use a key space that I have called default key space. And right now it is completely empty. So the idea is that we're going to put some things in here. Before we do that, though, let's have a look at the DataAPI. The DataAPI is actually how we're going to get all of our data into HCD today. So what I'm going to do is open up a new tab, and I'll paste that, and we'll say Swagger UI. So right now, as you can see, this is my my cluster endpoint up here, and port 8181 is for the DataAPI. And all I put on the end of this was Swagger-UI, and it found the rest of this here. So you can see that these are all of the commands that are available that you can run from RESTful endpoint here. So I can kind of open this up. I could do a create key space if I wanted to. inside of key spaces here. I could do a create collection. There's all kinds of things that that you can do here. And the cool thing too is that you could test this out. You put in your token, and you know, actually use this through the Swagger UI right here. It's pretty cool. So what we're going to do is we're actually going to have a look at Langflow. Now, we have Langflow tightly integrated with AstraDB, but for today, what I've done is I've actually spun up Langflow as a ECS Elastic Container Service inside of AWS. So let me go to tasks, and here we go. This is the public IP. So if I grab that IP, open up a new tab, and then Langflow should be 7860. All right, so we have Langflow. And like I said, if you haven't used Langflow, basically it's a component-based drag and drop GUI that lets you build generative AI applications. So you can build things with agents and chatbots and other, and the various components that go into making those pieces work. And you can do that all with Langflow. It's super cool. So I'm going to show you just how easy that is. We're going to build a simple AI-based shopping assistant here. So I'm going to say new flow, and you notice I get these three options that come up. One for basic prompting, one for vector store rag, another for a simple agent. We are going to go with vector store rag. So once you do this, you'll notice that you get two distinct flows here. You get the data loading flow down here, and then you also get the chat flow up here. So for now, we're going to focus on the data loading flow and get this built. So first things first, we are actually not using AstraDB. So in the components over here, we're going to go vector stores, and we have a special component for the Hyper-Converged database. We're just going to drag that out here. All right, which means that we can delete that and then tie up embeddings and tie up ingest and just connect everything like that. And it's super duper easy. So let's also have a look at the controls here. Our default namespace. Yeah, I want that viewable. And we are going to name that key space. There we go. That way it matches up with what I've already got built there. For the collection name, we're just going to say shopping AI vectors, just like that. All right, our username is going to be, just a second, I have to check name of my cluster one more time here. Oh, that's Jeremy. Let's go back to overview. Yep, leave. And I don't need that to be so big. All right, farewell to kings. That's it. So it's farewell to kings super user. Let me paste in my password. And then we have that URL endpoint that we used for the Swagger spec. We're going to go ahead and paste that in as well. And you can see that goes all the way up to the port number of 8181. Namespace is default key space. Okay, this should be okay. Let's go ahead and let's see. Let's get a file in here. Oh, hey, perfect. I have a file of product data that we're going to use for our shopping assistant. I think last week I talked a little bit about the e-commerce workshop that we used to do and the website that we had built. Well, this is the product data that's been exported from that, just in a CSV file. Pretty simple. So we'll go ahead and select that. And then the other part of this is that we are not using OpenAI. So let's go ahead and get that component out of here. We are going to want an embedding model. And since we're using Amazon, we're going to stick with Amazon for everything. Oh, don't mean to do that. There we go. Oh, and it comes preset with my AWS key and secret. All right, so let's just connect up our embeddings nodes. Okay, so if we did everything right, this should create this shopping AI vectors collection inside of our default key space, and it should load it with the product data that we have in this file here. So let's go ahead and just click the little run button up here. Oh, actually, you know what? I'm going to reduce our chunk overlap. There we go. Let's do that. Well, so far, so good. All right. You know, while that's running, I bet you, yeah, we can see it here. Let's have a look at CQL console. All right, so if we do use default key space, and I say desk tables, oh, look at that. We have a shopping AI vectors table out there. Outstanding. I mean, technically it's a collection, but when you're looking at it through CQL, it'll come back as a regular CQL table. So if I describe this shopping AI vectors table, this is actually what a collection looks like when you're viewing it as a CQL table. It has these kind of standard columns that we've built into it. You can see that we do have our query vector value here, which is a type vector, and the vector is a float of size 1536, which is common for most chat models. So yeah, as you can also see, you know, we have several storage attached indexes built onto this table as well, and that's really what kind of extends a lot of that functionality that we have from the collection and document paradigm that we don't normally get at the CQL level. So hey, this at least created the table. Let's see if we have any rows out here. So we can do a select star from shopping AI vectors. Oh, look at that. We have 24 rows. Outstanding. And as you can see, the vector embeddings themselves are, you know, visible here as that 1536 dimensional vector, which really is just made up of the I think the long description being you know, vectorized, if you will, into an embedding. So yeah, this looks like it worked. So if I go back to Langflow, okay, everything's good. All right, so we've managed to go ahead and load our data. Let's change our focus here to the chat flow. So the idea with the chat flow is that it's going to take this you know, kind of conversational approach. So the first thing we're going to start with is this chat input, which we default to. What is this document about? Well, I'm going to say something like, can you help me find a purple shirt? We'll just do that. Okay, so let's go through this bit by bit here. Now, we know we're not using AsterDB as a vector store, so let's get rid of that. Let's go down to the Hyper-Converged database component that we've already built, put together, and tested. We know it works. We've used it to load data. And again, kind of the cool thing in Langflow is it gets you this little drop down and you can say duplicate. And look at that. It just gives it right back to you. So, and I can take this up here. Now, this needs to be, let's see here. The data frame node goes up to the parser. And I think that's all we need to worry about for, oh, right. chat input message should go to the search query node. All right, and then we have OpenAI for embedding, so we also need to delete that and go down to Amazon Bedrock. And here we go. We can say duplicate. All right, now we can run this back up here and then connect up our embedding nodes as well. Okay. We're in really good shape here, actually. That should all be okay. So the next thing is that we do have to adjust the prompt a little bit. So if you have a look at the prompt here, it's pretty simple. Given the context above, please answer the question as best as possible. Well, you know, for our shopping assistant, that is just, that's not going to cut it. So I have some additional rules here that I have written up, and I'll just paste those in and say, you are a shopping assistant for the Astra Apparel online clothing store. You must only answer questions about Astra Apparel products. You may only use the product data in the provided context. This is important because otherwise what will happen is it'll just make up generic answers. And we've also told it, we're also going to tell it that it can't use any outside or other sources for answers. So it's restricted to the context that's in our database and that we have an HCD right now. And then, of course, you must format your responses about product data like, you know, product ID, description, image, etc. This last line here, telling a chatbot how to format the data you want back is actually really important if you're having an application sit on top of Langflow. All right, so this should be good. Let's do a check and save. Okay, now this actually broke one of our connections here. I just need to double check. Yeah, we need to run from the message to the question. So the idea here is the chat input goes to the prompt and it also goes to the search query for the database. The output from the database actually makes its way to the context, just like that. All right. So in this way, you know, we're having our conversational, you know, approach with the large language model, but our database is actually working as the context that it's going to base all that on. Okay. So we have another issue here. And again, we are not using OpenAI. So let me get rid of that. Now we need something different than an embedding model this time. For this one, we just need a straight up large language model. So again, we're going to grab Amazon Bedrock. I'm going to run prompt message to input and then message on the bottom here to the chat output. There we go. Already injected my ID and my access key. Outstanding. And I think the only other thing we need, oh, we are in US West 2. So let me just tick that. Oh, right. I can pick from all of these different Amazon large language models here through Bedrock. I believe the one that I've been using is this Claude Sonnet 3.5, 1022. That's the one I've been using. Okay, so that is our flow. Let's go ahead and click the run button here. A lot of pieces to this one, so let's just make sure that we're doing everything right here. And it worked. Oh, outstanding. Okay, so next we can have a look at the playground here, and you'll see what it did for the for like kind of the default you know, run that it goes through testing wise. It asks this question of, can you help me find a purple shirt? Oh, perfect. And yes, it found these purple shirts from DataStax. You know, so then I can say something like, can you help me find a hoodie? How about that? And this will spin for a little bit, but again, what it should do is work through that Claude Sonnet v5.3.5 model. Yeah, there we go. And then use HCD as our context, and you can see it found a few hoodies here. Outstanding. Yeah, there we go. There we go. Okay, so this is working. All right. Next would be to have something that can actually use this. So what we can do from here is if I click this Publish tab, you'll notice I get this API access option here. So you can actually like take this and run it as a curl command. You can kind of send in your different input message. I'm going to go ahead and click on the Python tab. You can see we have just some simple code here. There's a copy button here, and I can click that, and I don't think that works. So what I'm going to do, fortunately, I anticipated this. Oh, let's see. Is our other pod's not coming back? Oh, well. Okay. Let's go ahead and jump over here. Let's do touch, and we'll just call this shopping assistant.py. All right, and I'll actually use VI here. Oh, helps if I spell it right. There we go. Okay, let's go to insert mode. And fortunately, I have all of that text from here, and let's just go ahead and paste that in. All right, so as you can see, this is just a simple code that Langflow presented us, and it's got our input value of can you help me find a purple shirt, setting a request header of application JSON. Kind of the cool thing is that this is our own version of Langflow that we have running out there in AWS, so it doesn't require any access tokens or anything. But this is ephemeral. I'm going to take this down as soon as we're done here. But anyway, all right. So this all looks good. And then the idea is that it does a post request to that Langflow URL, and it goes to that flow that we just built. So let me do a right quit on that, and let's do Python shopping assistant py. And if we did everything right here, we should get a JSON response back. Come on. Come on. Hey, there we go. Look at that. Okay. Oh, it's saying it doesn't have access to that. That's really strange. Yeah, well, it's absolutely hitting our URL, but for some reason it's having a hard time with the flow there. Oh, you know what? I bet I know what the problem is. Let's go back to VI here. I bet you that this flow ID is not correct. Let's try that again. Oh yeah, look at that. It is different. Ha! All right. Oh, I hope I was able to copy that. Let me just, yeah, okay, that copied. Cool. All right, and then back to here. Okay. Let's go ahead and get rid of that old flow ID, which is what I tested with. And I can paste that in. Perfect. And we'll do a right quit, and let's rerun. Now this time it should actually bring data back about the purple. Oh, hey, here we go. Yes, I found the following purple shirts. There we go. So that was totally it. It was hitting an old flow ID that wasn't necessarily working. All right. So yeah, that's kind of a complete end-to-end. Obviously, if you wanted to do more, you absolutely could. I know for a demo at AWS reInvent this year, we actually had like a React.js shopping assistant that sat on top of a Langflow and kind of worked with that. So you could absolutely do more than just like a simple text-based Python approach like that. For some of you who haven't messed around with this a whole lot, one thing you can do too is you can go into the prompt and you can add other guardrails in here, like you must talk like you are a pirate, and you can do a save on that. And then if we go back to the playground and say, can you help me find a Cassandra shirt? Let's see how it answers. I'm kind of curious on this. Yar, matey, I spy several fine Cassandra shirts in our treasure chest. Here thy be. Yeah, so there we go. You get the idea, but just so you get a little example of what something like prompt engineering can do to kind of help round out your AI applications there. So yeah, this is all working. Let's see. So if I bounce back, yeah, we can go ahead and leave. Yeah, and I still have that one node that is just not coming back here. All right, I'm gonna have to dig into that eventually. But the good news is that even with one node down, of course, those of you who have used Cassandra before know that Cassandra and HCD can handle one node being down, and it's just not a big deal. So I guess this was a good example of in terms of building applications that are highly available, because even at 2/3 capacity, it still ran my demo flawlessly. So there we go. All right. Well, all right, everyone. That is pretty much all I had. Again, it was just a short introduction into the DataStax Hyper-Converged database. Showing that it's very much like Cassandra, with a little more advanced tooling and libraries behind it to kind of keep you on the cutting edge. You saw that it's highly available, just like Cassandra, as I was able to run through everything I just did with 2 out of 3 nodes. So hey, that's great. Kind of with HCD, you also get that DataAPI that's seamlessly integrated in. So you can go ahead and make all of these requests with, just through REST and without needing a special driver or anything to make that happen. So yeah, that is really about it. I see Michelle has posted in the chat here to see if there are any questions or anything. I don't see any at the moment. Oh, no questions today. Hey, outstanding. All right. Well, I guess that's all I had. Thank you, everyone who turned out for this one. I hope you all have a happy April Fool's Day. And yeah, I suppose we'll talk to you all later. All right.